Hi everyone, I hope everyone is doing well. So we're actually going to start a new unit. We are done with unit 11, but for right now we're just going to keep going and we're going to go on to unit 12. So we're going to start in the packet. You should have it already. When we saw each other last, I did give you this packet, but if not, if you go into Microsoft Teams and if you click on the class files, it should be in there. So if you had to print it out or if you could look through, on it from there, from the computer or from your phone and just write it down on a piece of paper, that's fine also. Okay, so we're going to start with day one. And day one is simply just evaluating interest problems, growth, and decay. So first thing is on the first page of day one, we're going to skip the do now questions. And we're going to go straight to the formulas to remember. So there's three formulas. It says simple interest, it says compounded n times a year, and then compounded continuously. So for simple interest, it's actually the same as exponential growth and decay, because we're going to use this for money problems. So obviously money is interest. But then we're also going to use this for a population question or a bacteria question. So that's where interest really wouldn't make sense. And that's where we would think of more of growth and decay. But it's the same formula. So for simple interest, growth, decay, pretty much they're all the same thing. And it's basically A equals P parentheses 1 plus for population or money that's growing minus if it's going down. R raised to the T. You may remember this formula. I believe you did it in Algebra 1, so it may seem a little bit familiar. So A is always going to be the final amount, or the amount at the end after X amount of time, blah, blah, all this happens, blah, blah, blah. A is the final amount that we want. The P is always going to be the initial, so the starting amount. So again, that's the starting amount of money that you're putting into the bank. That's the starting population. That's the starting number of bacteria. That's the start value. 1 is just the number 1. Again, you put a plus sign if it's growth. So if it's growth or if it's talking about money that is growing in an account, it's earning interest, you would put a plus sign. And if it's decay, so it would specifically only say it's bacteria that is decaying. That's when you would put a minus sign in the middle. Okay? And then R is going to be your rate. Now, your rate needs to be a decimal. So when we get to one of the problems, you'll see what I mean. You need to move your decimal point 2 places to the left to change it from a percent to a rate. And then last is time. So T stands for time. Okay, so it seems like a lot, but they all pretty much have the same exact letters. Okay, so you're not really remembering more than one thing for each different question. Okay, the second formula is compounded n times a year. So this is when you're dealing with a bank account, and instead of telling you that you earn interest every year, they're going to tell you that you earn interest monthly, or you earn interest quarterly, or you earn interest daily. Okay, so that'll be the compounded n times a year. That's what that means. And the formula looks very similar to this simple interest formula. And it's A equals P parentheses 1 plus R over N raised to the NT. So first off, it's always plus because your money's always growing when it's in a bank. And basically, if you look, the letters stay the same. Right? A is still going to be your final amount. P is still your starting value, so your starting amount. You still have R, so R is still your rate as a decimal, and you still have T, which is time. So there's only one new thing, and that is N. And in both places, it's talking about the same letter. And N is the number of times it's compounded. Okay. So now underneath here, we are going to write, so we're going to make a little box and we're going to put the common ones that you could see. So first thing, if they tell you that something is compounded annually, that's one time. So annually is one time a year, okay? Only once. Semi-annually, I only have one L's or two L's. That's why I'm not an English teacher. So a semi-annually is 2 times a year. Then you have quarterly. So quarterly would be 4 times in a year. There are 4 quarters to a year. You got monthly, which is 12. Weekly. So weekly, there are 52 weeks in a year. And the only other one they could say is daily. And daily, there is 365 days in a year. So for a question like this, it would say, blah, 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 deposits $100 into an account that is compounded quarterly at an interest rate of whatever percent. So that would tell you you have to use this formula because you need to plug in the 4 for N. Okay? And then our last formula is what we used if we see the word continuously. So that means that it is continuously gaining money, or it's continuously moving population-wise. So if you see the word compounded continuously, that is our clue that we're going to use this formula. A equals P times E raised to the RT. It's PERT. So compounded continuously PERT. Okay? So if you just got to remember that those two go together. If it says compounded continuously, that is the formula PERT. Now again, your A is still your final amount. Your P is still your starting amount. Your R is still your rate as a decimal. Your T is still time. So the only new thing here is this E. And E is, remember, that special button in your calculator. It is the inverse of ln, and it is a number. So E never gets plugged into anything. E is not a variable. Okay, so E, okay, stays in E. So it stays E, and remember, it's a button on your calculator. It's a value. Okay, so there are your 3 new formulas. So if you look, examples, there are 8 of them in day 1. I'm going to do 3 of them with you, and then you're going to try 4 through 8 on your own, kind of as classwork, and I'll see how you guys do, and you'll have till tomorrow to do it. Okay, so let's try the first one. So we're going to look at number 1, example number 1. Kathy deposits $25 into an investment account with an annual rate of 5% compounded annually. If she makes no other deposits, how much money will she have after 5 years? So here it's telling me right now here that it's compounded annually. So I'm going to use the second formula, okay, and I'm going to plug in a 1 for my N value. So I'm going to use the second formula. So P parentheses 1 plus R over N raised to the NT. So how much money will she have after 5 years? That is my final amount. So that is going to stay in A. P says it's my starting amount. So she is starting by depositing $25. So 25 goes into P. 1 plus. Now my rate is 5%. Okay, so 5%, you need to take your decimal, which would be here at the end, and you need to move it 2 places to the left. So 0.05 is what my R value is. So I'm going to have 0.05 over. Now N, remember we said, is how many times it's compounded. So it is compounded annually. Annually just means once a year. So it's just going to be over 1, which really doesn't change anything to that. And then it's raised to the N times T. So if I do 1 times the time. So how long are we doing this for? It says how much money will she have after 5 years? So 5 is your time. So that whole big formula, if you have the calculator or the calculator app that we use, you can actually plug that whole entire thing into the calculator at one time. Okay? So my calculator. We have 25 parentheses. So that this calculator is a little older. It's a lot easier on the ones that we have in the classroom because you can actually put in the fractions and stuff. So it makes it so much easier. All right, so we got 1 plus 0.05. Now remember, when I divide by 1, it's not going to change anything. So I'm just going to leave it as 0.05. And now I'm going to raise it to the 1 times 5 I know is 5. So when I press enter, my final amount, which is my A. Now, it doesn't tell you what to round to, but it's dealing with money. When you're dealing with money, you should have 2 decimal places. So you should have $31 and 0.907. So if I round that to the nearest 2 decimal places, it would be 0.91. So that's A, not a lot of money to put into a bank, $25, and B, after 5 years, she's not really making much money. Okay, but she did earn money. She earned, what, $6.91. Okay, so now we're going to flip the page. We are going to go to question number 2. So it says a population of fruit flies is increasing at a rate of 22.5% per hour. So every hour it's increasing. If the population has an original size of 10 fruit flies, what will the population be after 1 day? So first thing we need to realize is that they gave us our rate, which are our percentage, in hours, and they want to know how many we have after 1 day. So when we go to do our time, we can't plug in 1, okay? So when we go to do our time, we need to realize that 1 day is equal to 24 hours. And since it's increasing at a rate of 22% every hour, we're gonna actually plug in 24 for T. Okay, so now, it doesn't say anything about compounded. So it doesn't say compounded continuously. It doesn't say compounded whatever amount of time. So this is just the simple growth formula. So it's the first formula that we wrote down. So it's A equals P parentheses 1 plus R to the T. Simple growth formula. So what will the population be? So that is our A value. Our P value is in our original size, which is 10. 1 plus. Our rate is 22.5%. So 22.5, since it is a percent, I need to move my decimal 2 places to the left. So 0.225 is my rate. And I'm going to raise it 2 times. So now remember, we're going to plug in 24 hours. Okay, because if we plugged in 1, that wouldn't make sense. That would only be 1 hour, and that wouldn't tell us anything about the fruit flies. So we go 10 parentheses, 1 plus 0.225 raised to the 24. So we get 1,303.96. So now we're talking about fruit flies. You can't have a decimal of a fruit fly. So we're going to round this number up. So the 0.9 is going to round it to 1,304 fruit flies. So 1,304 fruit flies. That's a lot, okay? So that's a huge amount of flies. It's going from 10, and after 24 hours, there's 1,300 of them. Okay, and then we're going to do one more. I'm going to do number 3 with you. So Addison is going to invest in an account paying an interest rate of, now it doesn't have an interest rate, okay, so it is missing information. So we're going to use an interest rate of 6%. So for number 3, you have to add in the interest rate. It doesn't have an interest rate. So we're going to use that the rate is 6%. And then I have this keyword, ding, 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 compounded continuously. Compounded continuously PERT, okay? They go hand in hand. That's usually what I say. So Addison is going to invest in an account paying 6% interest rate compounded continuously. How much would Addison need to invest to the nearest dollar for the value of the account to reach $19,400 in 12 years. So this one is compounded continuously, so right off the bat we need to figure out the formula. It's PERT. P times E raised to the RT. Now for this one, we want to know how much she has to invest in order to make $19,400. So for this one, we actually know the A value. We actually know that she wants to have that much in the bank. We don't know what her P value is. Remember, E, you keep an E for right now, right? Because you're going to just plug it in the calculator. And now we raise it to the R, which is your rate, times the T. So our rate is 6%, so as a decimal, that would be 0.06 times your T, which we're doing 12 years. Now, P is being multiplied to this A. So since E is a number, since this is a number, and since this is a number, I actually can plug this into the calculator and find out what that value is. So in the calculator, I'm gonna go second ln, and notice the E pops up with the arrow for you. I'm gonna raise it to the 0.06 times 12, press enter. So this thing that I boxed is actually equal to 2.0544 dot dot dot. So I have P times 2.054 dot dot dot. So now if I look at my equation, if I want to get P by itself and it's being multiplied to this number, all I need to do is just divide it. So I'm going to divide by this number, this 2.054 number. So my calculator, I'm going to do 19,400 divided by, now I want to put that whole entire decimal in. I don't want to round it too soon. And then I'm going to press enter. And it says round to the nearest dollar. So P is equal to 9,442.99, which means to the nearest dollar it would be 9,443 is what she would have to invest. Okay? So I want you to try the rest of them. So I'm going to give you hints. For number 4, you need to do you have to do Kaylee and Joe and figure out who would have more in their account. So Kaylee is going to be using the compounded n times formula for Kaylee. And for Joe, he is compounded continuously. So for Joe, you're going to use the continuously, which is PERT. Okay. Number 5, compounded quarterly. So you're going to use the n times formula, which is the second formula. Number 6, compounded monthly. So again, you're going to use the n times formula again, the second formula. Number 7 is compounded continuously. So you're going to use PERT. And then number 8, you're actually going to use the first formula, but you're going to do decay because its bacteria is decaying. So you're going to use P1 minus R to the T. Okay, so I want you to try these and I want you to see how you do. Okay, I'll talk to you guys soon. Bye.